Day 17 of 90. Today we are covering process management with Python psutil for incident response. If you have ever responded to a compromised host, you know that knowing what is running and who owns it is step 1 in triage. We are going to build scripts that enumerate processes, monitor resource usage, trace network connections back to specific PIDs, and safely terminate suspicious activity while preserving forensic evidence. All of this runs on psutil, which ships on PyPI and works across Linux, Windows, and Mac OS without any OS-specific code. Let us start with the foundation, process enumeration. We call psutil.process_iter and pass it the specific fields we care about, PID, name, username, command, and create_time. For each process we wrap the access in a try except for no such process and access denied because processes can vanish between iteration and attribute access. We build a list of dictionaries, then sort by create_time descending. Why descending? Because during triage, the most recently spawned processes are the most interesting. A process running as system from a temp directory that started 2 minutes ago is a red flag. We print the top 20 and immediately have a ranked list of things to investigate. Next is resource monitoring. Crypto miners and exfiltration tools tend to spike CPU or memory. We prime the CPU counter with a throwaway call, sleep 1 second, then iterate processes again. For each one we call CPU_% with a short interval and grab memory_info RSS divided by a megabyte. Anything above our thresholds, say 50% CPU or 500 megabytes, gets flagged. We sort the results by CPU descending and print them as alerts. Running this in a loop every 30 seconds gives you a lightweight host-based anomaly detector. If the same PID appears in every sample and it is not a known workload, you escalate. Now the critical piece, mapping network connections to processes. We call psutil.net_connections with kind equals init and filter on established status. Each connection object gives us ladder, radder, and PID. We resolve the PID to a process name and username using psutil process. Then we group connections by process. The output shows you exactly which process is talking to which remote IP and port. Cross-reference those remote addresses against a threat intel feed or an allow list. Any process reaching out to an IP you do not recognize warrants immediate investigation. This is how you catch C2 beaconing programmatically instead of manually staring at Wireshark packet captures. Killing a process during incident response sounds simple, but doing it wrong destroys evidence. The pattern I use is suspend first, snapshot second, terminate third. We call prop suspend to freeze it, then capture its name, command line, username, open network connections, and open file handles into a dictionary. We write that dictionary to a timestamped JSON file. Only after the snapshot is saved do we call prop terminate and wait for it to exit. If the process is gone already, we catch no such process. If we lack permissions, we catch access denied and escalate to run with admin rights. The audit log is essential. In a real engagement you will need to justify every action you took during the incident. Let us tie everything together into a single triage script. We create a report dictionary with hostname, timestamp, total process count, high CPU processes, and external connections. For CPU, we iterate processes and flag anything above 40%. For network, we grab all established connections where the remote IP is not in RFC 1918 private ranges. We dump the whole thing to JSON. Run this on a suspect host and within seconds you have a snapshot that captures what is running, what is consuming resources, and what is talking externally. That is your starting point for deeper investigation. That wraps day 17. We covered process enumeration with security metadata, resource anomaly detection with multi-sample thresholds, network-to-process mapping for C2 detection, and safe termination with full audit logging. The key takeaway is that structured process data from psutil is vastly more useful than parsing shell command output during a live incident. Tomorrow on day 18 we tackle file system monitoring, watching for newly created or modified files that indicate attacker persistence mechanisms. See you then.